Dr. K. S. Ramakrishnan is working as an assistant professor, School of Education, Tamil Nadu Open University, Chennai 15. He has been teaching science education, environmental science, educational technology and research methodology in various colleges of education and Tamil Nadu Open University for the past 9 years. He has guided so many M.Ed, M.Phil and PhD students. His current research areas are environmental education, educational technology and media and communication. He has conducted various workshops on ICT usage in education, Wiki Educator, e-content development and educational research methodology. He had attended many online workshops on Moodle, learning analytics. He has published 6 books and many articles in national and international journals of repute. He regularly gives plenary and keynote speeches on environment and ICT related issues at various national and international conferences. He has delivered 28 episodes of the program Pudiyodor Ulagam at All India Radio, Chennai, related to various new developments in science and technology.
Dear viewers, welcome to UGC CSE program. Today, in environmental science, we are going to discuss about greenhouse effect. Greenhouse effect is one of the most serious problems threatening the environmental health of a globe. And today let us see what are the various problems associated with the greenhouse effect. Before that, what are the contents that we are going to discuss? The greenhouse effect, the causes of greenhouse effect and the greenhouse gases and the ways to reduce the greenhouse effect. So, these are all the contents that we will discuss in detail. See, first, what is greenhouse effect? When the production of infrared energy in the atmosphere warms a planet's surface, it is known as greenhouse effect. That means, the infrared energy is coming and part of the energy is reflected back. But if it is warming the earth surface, that is called greenhouse effect. Greenhouse effect is a natural phenomenon. See, look at the diagram. The greenhouse effect that is depicted symbolically and the energy that is coming from the sun and the part of energy is absorbed and the remaining that is reflected, and now the part of the energy which is absorbed, that is heating the earth surface. And so, this phenomenon is called the greenhouse effect. Now, let us see that in detail. See, there are two types of greenhouse effect. One is the natural greenhouse effect, which is keeping the earth's climate normal and comfortable, and the second, the release of gases like nitrous oxide, carbon dioxide, methane, ozone and water vapor. They cause the artificial or man-made greenhouse effect. The natural greenhouse effect that is depicted in this diagram. See, it is the subsurface, the land, the ocean and the ice. They are the lithosphere and the atmosphere, and about 31% of the reflected into space. That means, out of the 100% energy, 31% that is reflected back, and therefore, the remaining 69% that is absorbed by the earth's crust or lithosphere. And see the in detail. See, it is 100% and the 6% that is reflected by the atmosphere, 20% is reflected by the clouds and 4% is reflected from the earth surface and 51% that is absorbed by the land and 3% by the clouds and 16% is absorbed by the atmosphere, and then the remaining energy that is radiated back into the atmosphere. So, the radiated to space from clouds and atmosphere, that is 64% and the radiation absorbed by the atmosphere is 15% and radiated directly to space from earth, that is 6%, and therefore, in total If 100% energy is coming, you see 51% is absorbed by the lithosphere, and in total around some 69% is absorbed and 31% is radiated. And here the yellow color, that is the short wave. Short wave means high energy. So, when the energy is coming or when the waves are coming, they are high energy wave, and the red color, that is long wave, or less energy. That means high energy radiation that is falling on the earth, and it loses some energy and it is returning back as low energy, or in terms of wavelength we can say short waves are coming, they are radiating on the earth and they lose some energy and they are going back as long waves. So, it is the sum total of the energy radiation which is coming and which is going out. And when the man-made resources, that we are doing a lot of activities, we are burning fossil fuels or refrigerators or the aerosols or so many other activities that we are doing, and because of that what is happening, some part of energy that is locked in, that means the terrestrial radiation that is reflected back into the earth, and because of the greenhouse gases more radiation is absorbed, and therefore, the net temperature of the earth that is increased, and that is called the greenhouse effect. Therefore, beyond, that is in addition to the natural greenhouse effect, the man-made greenhouse effect is augmenting or it is enhancing the natural greenhouse effect, and that is increasing the temperature, and therefore, a lot of problems, the global warming, etc., they are caused. And now, what are the ways in which that human beings are enhancing the greenhouse effect? See, the burning of fossil fuels such as coal, oil, natural gases, cutting and burning trees, they are producing a lot of carbon dioxide, and the erosion and deforestation is increasing the amount of carbon dioxide in the atmosphere, and due to the loss of trees, photosynthesis cannot take place, and the industries are also the major cause of the greenhouse effect, and the chlorofluorocarbon CFC emitted by the refrigerators, aerosols and foaming agent, because they are the lightest particle, and therefore, they are also, that is causing the greenhouse effect, and the fire extinguished chemicals and cleaners are also some causes, and because of all these, the stability in the atmosphere is changed, and the population growth is also an indirect contributor, and therefore, by all these man-made activities, the greenhouse gases are trapping the heat and making the earth warmer. And now, let us go in detail how the greenhouse effect is caused. See, the visible light that enters the top of the earth atmosphere, already that we have discussed, around 70% of the earth absorbed by land, oceans, plants and other things. 30% is reflected back into the outer space by clouds, and this 70% does not stay on the earth forever, because okay, that 70% is coming, but that is not staying back entirely on the earth atmosphere, and the things that absorb the sun's heat, eventually they radiate a portion of that heat back out at a different wavelength, and therefore, out of that 70%, some amount is re-radiated, and therefore, sun rays are continuously hitting the earth, warming it, and the warm earth sends back the radiation into the space, cooling itself, and therefore, it is a continuous process, and that is maintaining the equilibrium, the temperature equilibrium of the earth. And now, some released radiation goes into space, and the rest of it is getting reflected back down to earth when they hit carbon dioxide. See, for example, when the radiated wave that is hitting a carbon dioxide particle, and they are re-radiated back into the earth surface, and like methane gas and water vapor also, and this trapped heat keep the earth warmer. As more energy is coming back to the earth from the atmosphere, because they are unable to go into the space, and therefore they are trapped. And what are causing the trapping of the energy? These particles such as the carbon dioxide, methane, chlorofluorocarbons, water vapor, and some other particles. And therefore, if their presence in the atmosphere is increasing, so naturally more and more energy is trapped into the earth surface, and therefore that is called the greenhouse effect. So, this greenhouse effect is keeping the earth warm, and therefore that we have seen clearly that because of the greenhouse effect, the earth become more warmer. And see how the atmosphere is influencing the radiation. See, look at the diagram. It is insolation, that means the incoming radiation, and reflection. Reflection means the incoming radiation that is exactly reflecting back. That phenomenon is called reflection. And reflection means simply it is redirection. There are two types of reflection. One is specular. Light is reflected with equal intensity, that means mirror. See, for example, you take up a mirror, and when the light is coming, the mirror is not absorbing any amount, and it is straight away it is radiated, and therefore this is called the specular radiation. And the other one, that is diffused radiation or scattering. So, the light is reflected in multiple directions, that is by snow. Therefore, some amount is absorbed also, and in reflection it is directed at the same angle. Suppose if it is an angle of reflection, and therefore, if it is an angle of incidence up to the normal, it is reflected in the same angle, and therefore, here the incident angle is equal to the reflected angle, but in scattering it is reflected in all the angles, and therefore, scattering happens in all directions. And now, the second one, that direction, this diagram, that is showing the scattering in all directions. And there are three types of scattering in the atmosphere. The first is the Rayleigh scattering, and the second is the Mie scattering, and third is the non-selective scattering. First, Rayleigh scattering, it involves gases smaller than the insolation wavelength. Suppose if the insolation wavelength, that is this much, and when the particle, the gas particle, that is smaller than the insolation wavelength. So, at this point or at this incident, then generally the Rayleigh scattering is happening. So, it scatters the light in all direction, and it is more effective in short wavelength. That means, the short wavelength means the violet and blue, and that is the reason why the sky is looking blue. And the second kind of wave, that is Mie scattering, it involves the aerosols, dust particle are larger than the gas molecule. See, for example, when the wavelength of the incoming radiation, that is larger than the gas particle. So, it is totally opposite to the first one, and in this condition, then the Mie scattering that is happening, and it is the forward scattering, and it is equally effective in all spectrum. So, in contrast to the first scattering, the first scattering was more effective in the short wavelength, but in contrast the Mie scattering, that is equally effective in all wavelength or all visible spectrum, that means from violet to red, and that is explaining the hazy gray days, and therefore, these are the more common scattering phenomena, and that is depicted in the diagram also. So, the first one, that is the Rayleigh scattering, and the second one, that is the Mie scattering, and there is another kind of scattering, that is called non-selective scattering, and it happens when the atmospheric particles are much larger than the wavelength of incoming radiation. That means, the particles are so big in comparison with the wavelength. That is, the water droplets are cloud, because the cloud, the particles are much larger than the incoming radiation, and therefore, here it is a non-selective scattering, and therefore, what happens? It is acting like a lens, it scatters wavelength equally to create a white appearance, and that is the reason why the clouds are appearing white in color. And therefore, again that I will tell in detail, there are three kinds of scattering: the Rayleigh scattering, the second Mie scattering, and the third, that is the non-selective scattering. All these are depending upon the comparison or the relative wavelength in comparison with the particles. So, when the particles are very small or equal or large, depending upon that, the scattering is happening. So, this is a non-selective scattering. See, look at the cloud and they are white in color, because the cloud particles are so large and therefore, they are non-selective. Let us have a short break. Welcome back, and now next phenomenon, that is the atmosphere is influencing the radiation. So, what happens? They are absorbing the radiation also, and therefore, suppose if the particle is absorbing the radiation, what happens? The particle becomes somewhat warm, and that is depicted by the red color, and therefore, the outgoing radiation, that is longer wavelength, and that is depicted by the red color. And therefore, this phenomenon, that is the major cause for the greenhouse effect. And the same, the transparent to solar short wave, and therefore, the atmosphere, that is transparent to the short wave, and that is given by the blue color, and for the red color, and they are opaque. And therefore, the same atmosphere which was transparent for the short wavelength, that is opaque for the longer wavelength, and therefore, some energy is trapped. And what are the major greenhouse gases? Carbon dioxide, water vapor, and methane. Now, let us discuss in detail how they are affecting. See, here the absorption, that is depicted in the picture. See, look at the diagram, and here the atmosphere, water, the carbon dioxide and ozone, they are absorbing large amount of heat, and the nitrous oxide and methane also, and therefore, in comparison with the methane and nitrous oxide, the water vapor, carbon dioxide, etc., they are absorbing large amount of heat, that is depicted in this figure. And what is the composition? Nitrogen 78%, oxygen 20%, and argon 0.934%, carbon dioxide, the normal concentration, that is 0.036%, and methane 1.7 ppmv, hydrogen 0.55, and nitrous oxides 0.31 ppmv, and the ozone 10 to 500 ppbv, and that is in the troposphere, and in the stratosphere it is 0.5 to 10 ppmv in the stratosphere, and water 100 pptv, that is 4% water vapor. and wherever the red bullets are there, and they are the greenhouse gases and they cause the greenhouse. So, this is given. The definition for greenhouse gases is given: any gas that accumulates lower energy infrared radiation, that is called greenhouse gases. Now, let us see water vapor. The water vapor is produced by the sun's heat emission, because the water is evaporating from ocean, river and water bodies, and maximum they consist of 4% of the air, and they are causing about 2/3 of the greenhouse effect. Look at the previous diagram. Here you can see the water vapor, they are absorbing a large amount of heat. Now, we can say the water vapor that is causing about 2/3 of the greenhouse effect, and the higher the temperature, more water vapor, and therefore, the more greenhouse effect. So, in that way the water vapor that is causing the greenhouse effect. And the next is carbon dioxide. They are formed naturally and man-made also, and that natural carbon dioxide from the mines, or when the forest fire or the volcanic action, and they are forming some natural carbon dioxide, and the man-made carbon dioxide, that is by the burning of the coal, fossil fuel, wood, etc. And the human beings also, we are inhaling oxygen and we are releasing the carbon dioxide, and therefore, to a lesser quantity they are the carbon dioxide is released by the human beings also, and therefore, the carbon dioxide is accounting for 385 ppm parts per million of the atmosphere, and they are responsible for 25% of the natural greenhouse effect, and the carbon sinks help remove the carbon dioxide emission from the air. And the next is methane, CH4. It is produced both by human source and naturally, because from the marshy lands a lot of methane is produced, and animals, they are also producing some amount of methane, and artificially that we are producing methane. And so, less quantities of methane in atmosphere than the carbon dioxide, and the methane is more capable of absorbing the thermal energy than carbon dioxide molecule. Their capability is more, and therefore, they are also causing the greenhouse effect. And the importance of methane is that it is 23 times more powerful as a greenhouse gas than carbon dioxide, and therefore, generally people are thinking that the carbon dioxide alone is causing the greenhouse effect. Carbon dioxide is more dangerous, but the point is that the methane, even though it is available or it is present in less quantity, it is 23 times more powerful than carbon dioxide in producing the greenhouse effect. And the livestock sector, they are the major player, accounting for 35 to 40% of global anthropogenic emission of methane, and therefore, the livestock sector, it is not the man-made, it is natural, and therefore, the livestock sector also is producing 35 to 40% of global emission of methane, and therefore, all these are accounting for greenhouse effect. See, the livestock sector is responsible for 18% of total greenhouse gas emissions, and therefore, out of 100%, 18% is caused by the livestock, and therefore, we can conclude that consuming less meat, that can help reducing the global warming than not driving cars. And therefore, that it is somewhat paradoxical that consuming less meat, that is more effective in solving or reducing the greenhouse effect than driving the car. And therefore, this is the fact about the importance of methane, and that is the importance of the livestock. And the next is ozone, and the ozone is existing naturally, and in the upper atmosphere the ozone layer is there. Ozone is O3, and that is protecting the earth from the ultraviolet rays. See, for example, the upper crust, the ozone layer is there, and we know that the sun's energy, that is containing the high energy ultraviolet radiation, and in case if the ozone layer is not there, what will happen? They are directly entering into the earth surface, and they are causing cancers and some other troubles, health hazards also. And therefore, the ozone layer, that is protecting the human being from the entry of ultraviolet rays. At the same time, the ozone layer, that is acting as a greenhouse gas in the troposphere also, and therefore, we can say on one side it is a protector, on the other side it is causing some part of greenhouse effect also. And then comes the nitrous oxide, that is produced naturally and human resources also, because the bacterial action, and they are also causing some amount of nitrous oxide, and human sources from agricultural, fertilizer, and so these industries are producing some amount of nitrous oxide. And the nitrous oxide, they are having lower density in the atmosphere than carbon dioxide, and the molecules of nitrous oxide, they are 300 times more effective as carbon dioxide, and therefore, you can imagine how powerful the nitrous oxide in producing the greenhouse effect. You see, look, 300 times, and it is also a cause. See, here the sources of nitrous oxide emissions are given, and what are the major sources? The fertilizer, the synthetic soil fertilizer, and that is causing the major portion of the nitrous oxide. And here the mobile or stationary sources of fossil fuel combustion. See, when the fossil fuel like coal or petroleum, they are combusted and they are producing some amount, and then the livestock manure, that is also causing some amount of nitrous oxide, and the other sources. And therefore, from the diagram we can see mostly the synthetic soil fertilizer is causing around some 75 to 80% of the nitrous oxide. And see, the nitrous oxide, that is 300 times more effective, and therefore, we should be very careful with the nitrous oxide and methane than the carbon dioxide. And the aerosol, see, what is the aerosol? They are the clumps of molecule 1 micron in diameter. 1 micron means 10 power minus 6 meter, that is called 1 micrometer or micron, and therefore, they are the clumps of molecule in micrometer range. And the sulfate aerosol, that is formed when sulfur dioxide is oxidized, and they are reflecting the incoming solar radiation, and they are increasing the albedo. See, what is albedo? The reflecting power of a surface, that is called albedo, and therefore, the aerosol is also causing the reflection, and therefore, they are increasing the albedo, and they are forming haze in the atmosphere directly linked to air pollution. And therefore, from the surface, this aerosol, they are directly going into the atmosphere, and they are forming the haze, and therefore, they are also causing air pollution. See, they have a cooling influence on the climate, and to some extent, they are offset the warming from the greenhouse gases. And the short resident times in atmosphere, that means the aerosols cannot stay in the atmosphere for a long time, and they can stay very short duration. And another point, they are not well mixed with the atmosphere also. See, for example, the carbon dioxide, that is well mixing with the atmosphere, but on the other hand, the aerosols are not that much well mixing with the atmosphere, and therefore, they are found very close to their sources, and because of a very short stay, and their impact is much more uncertain than the effect of greenhouse gases. But anyhow, as they are also staying in the atmosphere, they are also reflecting because they are increasing the albedo, and therefore, they are also contributing to the greenhouse effect, but still it is not certain that in what way that they are contributing, that is still to some extent uncertain. See, how to prevent the man-made greenhouse effect? Avoid wasteful buying, switch off electrical gadgets, judicious use of water, and use of natural gas over coal and oil, and instead of using the fossil fuel, that we may walk to places or use bicycle, and form an environmental club and get involved in planting of trees. And there are 3 R's: reduce the needs, reuse the items till they are no longer useful, and the recycling if possible. And therefore, the 3 R's: reuse, reduce and recycle. And summary, in this episode that we have seen the greenhouse effects, its causes, the greenhouse gases, and the types of reflection, the composition of particles in the atmosphere, etc. have been discussed in detail, and the ways to reduce greenhouse effect have also been elaborated. Now, there are some questions. First question, define greenhouse effect. Second, mention some greenhouse gases. And third, distinguish various methods of reflection of sunlight by the atmospheric particles. And the fourth, why it is told that consuming less meat can help reducing the global warming than not driving cars. And the last question, what are 3 R's? Give one example for each. Okay, audience, thank you. Have a nice time.